Hello, my name is Rebecca White, and this is my review of Chapter 6 of Investigating Oceanography, the Atmosphere and the Oceans. A couple of the things that I learned were, first of all, about Earth's heat budget. I didn't realize just how specific Earth's uh, input and output flow had to be um, between the incoming solar radiation and the outgoing infrared and light radiation, and that they had a very specific, like, if 10% goes in, 10% has to come out. If 100% goes in, 100% has to come out, or else things get thrown really out of whack. Another thing I found interesting was that I knew that sea ice was a thing, but I didn't know that the thin sheets would break up to form what they called pancakes. I also didn't know that these pieces of ice can be considered fast, drift, or pack ice. Um, so I found that really interesting that there were so many different types of considerations of ice. Another thing I found interesting, or that I learned, was the topographic effect, which I also did not know was like something so specific, like um, that it had such a huge impact on how like one side of a mountain could be a complete oasis while the other side could be a desert, because the mountain blocks off all of that moist air on one side, leaving the dry air to move over a desert on the other side. So some things I found interesting were, first of all, going back to the different types of ice with the sea ice. Usually, when you think of something being fast, you think of movement and um, change and things like that. But in this case, it means like steadfast. So this ice is like anchored and it's not moving. Drift ice is one that I did think was pretty obvious. I mean, it's drifting, it's moving along freely. And the pack ice is nearly continuous, and I think of like icebergs in the pictures of um, polar bears on icebergs in Antarctica and stuff like that. And another thing I found interesting was about icebergs, and how only 12% of the total iceberg is actually visible to people. When you think of like an iceberg, I tend to think of the Titanic and how something that massive took down an ocean liner, and yet the part that was that massive that people could see was only actually 12% of the iceberg. So that had to be a pretty huge iceberg with the other 88% under the water. I also thought it was really interesting that the weather in areas covered by circulation cells tend to be fairly consistent to the description of those cells. For example, it says that the trade winds area tends to be wet, high precipitation, and hot. And if you look at like normal weather patterns in Florida, which is in the trade winds area and close to the equator, it's usually hot and rains a lot, and it's usually wet due to the frequent rains and high humidity. I would like to learn a little bit more about the Coriolis effect and how it works and how it impacts things like weather and greenhouse gases, because I just didn't really know a lot about it before. I also want to know more about the monsoon effect, um, where it's most likely to take place, and how professionals can predict if a monsoon is going to happen so that they can help to keep people safe. And I also was curious as to how they came up with the different names of a hurricane, like typhoon and cyclones, and how do they determine those, and what locations those are used in. So my three questions are: what tools did scientists use to determine the height of the atmospheric layers, and how did they know when they changed from one layer to the next? Why don't hurricanes form at the equator? And do greenhouse gases have a significant effect on hurricanes and monsoons? Thanks.